Recording in progress. So basically, we'll go to exercise 16A, question number 4, sub question 2. No, because 4 question I'll not do right now. I'll be guiding you on some other problems. Okay. So exercise 16A. Let's go to question number 5, sub question 2. Okay. Integration of 1 and root 3 dx 1 plus x square. So this is equal to 1 upon 1 plus x square dx root 3 and 1. So this is equal to tan inverse x root 3 and 1. Box minus box. Wherever there is x, put root 3. And wherever there is x, put the lower limit, that is 1. This we have discussed in the first session. Tan inverse root 3 is 60 degree and tan inverse 1 is 45 degrees. So this is equal to 15 degrees. Okay. Convert it into radians. Convert it into radians. So 15 into pi by 180. Okay. So pi by 12. Please copy this. Yeah. Are you done with this? Are you done with this?
I'll have to keep you maid. She will come morning.
Okay. 5 sub question 3. Integration of x square minus 4 dx. So this is pi and this is 3. Now initial few sessions on definite integrals is it's basic integration. So if the degree of the numerator and degree of the denominator is same, what we do? We make numerator same as denominator. So we made it same, x square minus 4 and this will be plus 4. Okay. When the degree is same, make numerator same as denominator. Now split. Five and 3. This will give me 1. Okay. So I'll just write this again. 4 is a constant. X square minus 2 square. So this is x and this is a. Individual integration. Integration of 1 is x plus 4 1 upon 2a log mod x minus a upon x plus a. Upper limit and lower limit. 4 upon 2 is 2. Put the value of a as 2. Okay. So 2 into 1 upon 2 log mod x minus 2 upon x plus 2. Upper limit and lower limit. Again, this 2 and 2 will get cancelled. After this, I'm going to do box minus box. After this, I'm going to do box minus box. Okay. Now in the first box, wherever there is x, I'm going to put 5. And in the second box, wherever there is x, I'm going to put 3. Okay. So 5 plus log mod 5 minus 2 upon 5 plus 2 and 3 plus log mod 3 minus 2 upon 3 plus 2. Wherever there is x, I'm putting 5 in the first box, and in the second box, I'm putting x as 3. X as 3. Okay. 5 minus 3 will give me 2 log mod 3 by 7 minus into plus is minus log mod 1 by 5 log a minus log b log a divided by b. So 2 plus log 15 by 7. That is the final answer. This is the final answer. 2 plus log 15 by 7. Okay. Chalo, give me a feedback. Have you understood this? Okay. Let's go to the next problem. Question number 5, sub question 4. Integration 0 to a dx upon root ax minus x square. Rearrange. This is the revision of in-depth 3. Rearrange. Take common. You cannot take minus sign outside the root because it will be a complex number otherwise. Okay. Minus within the root is a complex number. So don't take that minus within the root, outside the root. So half into coefficient of a. Coefficient of x is minus a. So a by 2 the whole square. So we are going to add a by 2 the whole square and we are going to subtract a by 2 the whole square. We are going to add a by 2 the whole square. We are going to subtract a by 2 the whole square. Every opening bracket should have a closing bracket. First 3 terms and last 2 terms. Now there are no 2 terms. There is only 1 term. Okay. x minus a by 2 the whole square minus a by 2 the whole square dx. So 0 to a 1 upon root of a by 2 the whole square minus x minus a by 2 the whole square. I'm taking this minus sign inside. When I take this minus sign inside, the terms get reversed. Now this is a simple formula, 1 upon root a square minus x square. So the answer for this particular formula is sine inverse x by a. It is sine inverse x by a. Okay, upper limit and lower limit. Upper limit is a and lower limit is 0. Now put the value of x and a. X is x minus a by 2 and this is a by 2 upon d by dx of x minus a by 2 upon d by dx of x minus a by 2, which is equal to 1. Derivative of x minus a by 2 is equal to 1. So this is equal to sine inverse of 2x minus a upon a and 0. A and 0. Now we have simplified this, we have integrated, we have simplified. Now this is box minus box, box minus box. Sine inverse of 2a minus a by a and sine inverse of 0 minus a by a. So this is equal to sine inverse of 1 minus sine inverse of minus 1. Sine inverse of minus 1 is minus sine inverse 1. Okay, sine inverse of minus x is minus sine inverse x. So this is going to be pi. This is going to be pi. Okay. Question number 6, sub question 2, mark it done. It's for self-study. 6 sub question 2, it's a similar sum like this one. Do it for self-study. Let's go to question number 6, sub question 1. 6 sub question 1. Okay. Integration 3 and 1 x square x plus 1 dx. X square x plus 1 dx. Okay. Now this problem can be solved using two different types of partial fractions. First of all, the degree of the numerator is 0, degree of the denominator is 3, x square into x is x cube. So we can apply partial fraction. Okay. So there are two different partial fractions that we can apply, repeated linear or linear and quadratic. Okay, linear and quadratic. That also we can do. Fine. So let this be equation number one. So 1 upon x square x plus 1, 1 upon x square x plus 1 is equal to the term which is not repeated, that is x plus 1. Then x is repeated twice. So b upon x plus c upon x square. Batch 2, have you completed all four types of partial fractions with me? Or only three? Yes, anyone? This is the third type. Yes, batch 2. Have you completed all three types with me? Okay, fine, great. So this is the third type. Equation number 2. So 1 upon x square x plus 1. I'll take LCM x plus 1 into x square. If you remember, out of the square term, you should take the square term as the LCM. A into, from this eliminate x plus 1. So it is going to be x square b into, from this eliminate x. So it is going to be x into x plus 1 plus c into, from this eliminate x square. So it is going to be only x plus 1. Now cancel the common denominator on both the sides. So we are left with 1 is equal to ax square bx x plus 1 c into x plus 1. Okay. Now critical values. Equate x plus 1 to 0, you get x is equal to minus 1. So put x equal to minus 1 in 3. This is equation number 3. So put x equal to minus 1. You'll get something as a. Will you tell me what are you getting as a? What is a? What is a? A is equal to 1. Second critical value. Equate x to 0. So this will be 0. Put x equal to 0 in 3. So c is equal to what? Will you tell me, guys? What is c? C is equal to 1. Now third time, if we take x square equal to 0, we'll get x is equal to 0. So don't put again x as 0. We'll get the same value of c. So now put any other value of x as anything apart from minus 1 and 0. So put x is equal to 1. Tell me the value of b, everyone. Come on. and put the value of A and C also. X is equal to 1, take a simple value, non-negative value. Tell me the value of B. Tell me the value of B. I'm waiting for some more answers. -1. Perfect. Put the value of ABC into. So from 2, 1 upon x square, x plus 1 is equal to a 1 upon x plus 1 plus 1 upon x plus minus 1 upon x square. From 1, integration 1 upon x plus 1 plus 1 upon x plus into minus is minus, take x square up, x raised to -2. Take the power up if and only if the value of the power is more than 1. If it is not more than 1, 1 upon x, don't take x as x raised to -1 over here. Okay, if it is more than 1, then only take it up. Upper limit and lower limit. Upper limit is 3, lower limit is 1. Guys, is this individual integration? Is this individual integration? Yes. 1 upon x plus 1 will be compared with 1 upon x formula. So log mod x plus 1 upon d by dx of x1 plus 1, which is 1, that's fine. Plus log x minus x raised to -1 upon x minus 1. 3 and 1. Okay. X raised to -2 I've done. X raised to n formula over here. Log a plus log b. Log a into b. Plus 1 upon x. This minus minus is plus, and x raised to -1 goes down. It becomes 1 upon x. It becomes 1 upon x. Now it is going to be box minus box. Log 3 into 3 plus 1 plus 1 upon 3 minus log 1 into 1 plus 1 plus 1 upon 1. So this is log 12 and log 6. Log 12. Now 1 by 3 minus 1, this is going to be 1 by 3 minus 1, because there is a minus sign outside. Okay. What is 1 by 3 minus 1? It's -2 by 3, right? minus log 2. Okay, I think somewhere some value has gone wrong. Is b minus 1? Because the answer given in the textbook is correct. It's not incorrect. Is b minus 1, guys? Ha, I have substituted wrong. Sorry. In place of b, I have put c, and in place of c, I have put b. Okay, so sorry for that. B is minus 1, so minus 1 should be in the middle over here, and C is plus 1. Okay, so be careful of all these things as well. So this is going to be minus, and this is going to be plus. Sorry for this. Okay, so this is minus over here, and this is plus over here. Make these changes, guys. Log A minus log B, log A upon B, plus upon minus is minus 1 upon x. Okay, 3 and 1. Box minus box, 3 plus 1 upon 3, minus 1 upon 3, 1 plus 1 upon 1, minus 1 upon 1. Log 4 by 3 minus 1 by 3, minus log 2 plus 1. 1 minus 1 by 3 is 2 by 3. Log A minus log B, log A divided by B. So 4 by 3 divided by 2, which is 2 by 3. So plus log 2 by 3. Okay. Is it matching with the textbook answer now? Is it matching with the textbook answer? So guys, tell me, have you understood this problem? Okay. Question number 6, sub question 3. Integration log x 1 plus x the whole square, 3 and 1. Log x 1 plus x raised to minus 2 dx, 3 and 1. Logarithmic term which is u, and algebraic term x raised to n term which is v. No need to interchange this. No need to interchange this. Okay. So u v integration by parts, u integration v dx, bigger integration d by dx of u, smaller integration v dx, bracket close dx. Now, first and foremost, okay, we are supposed to apply integration by parts. So let us do that. For time being, we are going to ignore the upper limit and lower limit because everything will be too heavily cramped up. Copy. I will make a working note. Integration of 1 plus x raised to minus 2 x raised to n plus 1 upon n plus 1. So this is minus 1 upon 1 plus x. Minus goes up and this term comes down. Okay. So this you can write besides the main steps so that again and again you don't have to write this. Fine. Upon dy dx of 1 plus x. That is 1. Hence I'm not writing that. Chain rule part is 1. Okay. So now what I'm going to do is log x into minus 1 upon 1 plus x dy dx of log x is 1 upon x and this is minus 1 upon 1 plus x dx. Okay, let this be I. Now since we have integrated this entirely, this first part we have integrated, we're just going to simplify and put the limits. Simplify and put the limits. Now this minus and minus is plus, minus and minus is plus. Okay, x 1 plus x dx 3 and 1, 3 and 1. Okay, let this be equation number 1. This is I1 and this is I2. And I1 part we already have solved. So we need not integrate it. We just have to do box minus box. But I2, yes, of course, we have to solve. So I'm just waiting for you to copy this. I1. No need to integrate. We have done that. Application of upper limit and lower limit. Minus log 3 upon 1 plus 3 minus log 1 upon 1 plus 1. Now entire second bracket is going to be 0. This entire bracket will be 0. Can someone tell me why? Can someone tell me why? Because log 1 is 0, correct? The answer is right there. The log 1 value is 0. So this is minus log 3 upon 4. Okay, log 1 value is 0. So I1 value we got minus log 3 upon 4. I2, integration. I'll take you to I2. 1 upon x, 1 plus x. Now this is PF type 1, but then I will avoid that. Okay. This is quadratic, I'll just complete squares. Half into coefficient of x. Coefficient of x is 1, so half square. First three terms, last two terms. This is I2. First three terms, last two terms. Okay. Proceed. So x plus half the whole square. Minus half square. Minus half square. 3 and 1. So this is x and this is a. 1 upon 2a log mod x minus a upon x plus a. So 1 upon 2a x plus half minus half x plus half plus half. So 2 and 2 is getting cancelled. Chain rule part will be 1 divided x of x plus half is 1. So that need not be included. So is this x upon x plus 1? Is this x upon x plus 1? So log x upon x plus 1. 3 and 1. So log 3 upon 3 plus 1 minus log 1 upon 1 plus 1. Box minus box. Log 3 by 4 minus log 1 by 2. Log 3 by 4 divided by 1 by 2. So this is going to be log 3 by 2. This is going to be log 3 by 2. But then we require log 2 something in the solution. We'll just keep it log 3 minus log 2. Again, we'll just open it, okay? Log 3 minus log. So this is I2, guys, this is I2. We require log 2 in the problem. So again, I opened this. Log A upon B is log A minus log B, okay? Now from 1, I is equal to I1 plus I2. What is I1? What is I1? Minus log 3 by 4. I2. What is I2? Log 3 minus log 2. Okay. Now solve this. Take log 3 common. Minus 1 by 4 plus 1. So 4 minus 1, that is 3. Hence proved. Is this what is required, guys? Is this what is required? Log 3 into 3 by 4. Is this what is required? Yes, those who are attending, just please reward. Have you understood the problem? Okay. 7 sub question 1. Integration of x e raised to 4x. There's a printing error. It should be e raised to 4x. As per the light rule, this is algebraic and this is exponential. So we are in the proper order. So this is u and this is v. U integration v dx minus bigger integration dy dx of u. Okay, this formula you are well aware of. So x e raised to 4x. Yes. Now, can someone tell me what is the integration of e raised to 4x? What is the integration of e raised to 4x? Come on. E raised to 4x by 4. Correct. So copy it here. Yeah. So x e raised to 4x by 4. X e raised to 4x by 4. I'll put entire box now because there is no integration. Okay. Acha, now see, do that in the next step. Whenever it is integration by parts and definite integrals, don't be in a hurry to substitute the limits. Just wait. This is 3, this is 1 and this is 0. dy dx of x is dy dx of x is 1 into e raised to 4x by 4. Okay. Now there is no integration over here. Just put the box bracket and then upper limit and lower limit. minus 1 by 4 outside e raised to 4x dx. E raised to 4x dx. Now no need of I1, I2 over here. It's pretty simple. You want to do, you can do as well. Box minus 1 by 4 e raised to 4x is e raised to 4x by 4. Upper limit and lower limit. So 1 e raised to 4 into 1 by 4, 0 e raised to 4 into 0 by 4. The second box, this box will be what? Anyone? What this will be? What this is going to be? 0. This is going to be 0. Okay. So I is equal to e raised to 4 by 4 minus 1 by 16. I'll just multiply this first. Both are constants. E raised to 4 by 4 minus 1 by 16 e raised to 4x 1 and 0. So e raised to 4 by 4 minus 1 by 16 box minus box 4 into 1 4 into 0. So e raised to 4 by 4 minus 1 by 16 e raised to 4 minus e raised to 1 e raised to 0 which is 1, sorry. Okay. So the answer over here will be e raised to 4 by 4 minus e raised to 4 by 16 plus 1 by 16. Are you getting the same thing? Textbook answer is a bit incorrect because I think they have taken something wrong over there. Okay. Guys, are you getting this? Yes or no? Okay. Let's go to 8 sub question 1. Integration of 0 to pi by 2 x square sin x. U and V. LIATE. Algebraic and trigonometric. X square is algebraic. Sin x is trigonometric. U integration V dx. Bigger integration d by dx of u. V dx bracket close dx. X square sin x dx, dy dx of x square, integration of sin x dx, bracket close dx, bracket close dx. Don't be in a hurry to put upper limit and lower limit whenever it is integration by parts in definite integrals. So sin x integration is minus cos x. Immediately I put a bracket. That is expected from you as well. 2x into minus cos x. So minus x square cos x. Now there is no integration sign. So I am just putting upper limit and lower limit. Pi by 2 and 0. Plus 2. How plus? Minus into minus is plus. 2 outside. X cos x dx. Box minus box. 2x cos x dx. Minus pi square by 4. Put x ka value as pi by 2. And in the second bracket put x value as 0. Second bracket is going to be 0 because 0 square into cos 0 is 0. What about the first bracket? What about the first bracket? Those who are attending can tell me. Will you tell me? What about the first bracket? 0, correct, because cos 90 is 0. So the first bracket is also 0. Both the brackets are going to be 0. So we are just left with 2 x cos x. We just put a bracket over here because of the 2. Upper limit and lower limit is also there. Just remember that. Okay. So I 2 x integration of cos x dx, bigger integration, dy dx of x, cos x dx, bracket close dx, curly bracket close. X sin x. Now we can just put the bracket, box bracket, pi by 2 and 0, bigger integration 1 into sin x dx. Box minus box. And 1 into sin x is sin x. Now you can put the upper limit and lower limit. So pi by 2 sin pi by 2, 0 sin 0. Second bracket is going to be 0. What about the first bracket? What about the first bracket? What about the first bracket? First bracket is going to be pi by 2 because sin pi by 2 is 1. So it is only going to be pi by 2. Okay. And this sin x is going to be minus cos x. And that minus and this minus subsequently will become plus. Okay. So 2 pi by 2 minus minus cos x, pi by 2 and 0. Minus minus is plus, pi by 2 and 0. Now again box minus box. Cos pi by 2 minus cos 0. Cos 90 is 0 and cos 0 is 1. Okay. So this is the answer. You can multiply 2. So pi minus 2. This becomes the answer. Any doubts, any queries? The problems are going to be lengthy in this particular chapter. So ask any doubts. If any doubts are there, please ask. Let's go to the next problem. That is question number 10, sub question 1. Zero to a 3x squared dx is equal to 8. 3x cubed by 3. 8 to 0 is equal to 8. 3 cancel. Only x cube is left. Okay. Box minus box. So a cube minus 0 cube. So a cube is equal to 8. So a cube is equal to 2 cube. A cube minus 2 cube is equal to 0. What is a cube minus b cube? A minus b. See, we are doing this because we cannot directly say that a is equal to 2 because a cube is there. So there will be three different roots of a, three values of a. We cannot just be satisfied with one value, that is 2. Okay. First copy this much. Okay, so a cube minus b cube, guys. So that is a minus b, a square plus ab plus b square equal to 0. So two cases. A minus 2 equal to 0. So a is equal to 2. A square plus 2a plus 4 is equal to 0. So we'll find out delta. B square minus 4ac over here. What is b? B is 2. 4ac. So 4 minus 16. Okay, less than 0. Delta less than 0. Roots are complex. Okay, so we are not getting real roots in this. Therefore, the answer of A is only 2 because the other two roots are complex. Other two roots are complex. Other two roots are complex. Guys, you understood this problem? Next question, 10 sub question 2. B2A x cube dx is equal to 0. So x raised to 4 upon 4, V2A is equal to 0. Box minus box equal to 0. Upper limit and then lower limit. So B square plus A square, B square minus A square is equal to 0. 4 went over here. B square plus A square, B square minus A square is equal to 0. So two cases over here. B square plus A square equal to 0 or B square minus A square is equal to 0. Okay. So B square is equal to negative A square. Now A square is always positive. So positive into negative is negative, but in B square it can never be negative. Okay. B square always has to be positive. B square cannot be negative. So it is negative over here. So case invalid because you put any value of B, B square is going to be positive, but then we are getting negative over here. B square is equal to A square. Therefore, B is equal to plus minus A. Very important. It's plus minus A because A square is also A square and minus A the whole square is also A square. We are going to complete question 10, 3 and 4 also. So just be mentally prepared. Now next integral. Next integral is B to A x square dx. So integrate this x cube by 3 B to A. Okay. And this value is equal to 2 by 3. Okay. So this value is equal to 2 by 3. So x cube by 3, 2 by 3. 3 will get cancelled on both the sides. So box minus box. Box minus box is equal to 2. B cube minus A cube is equal to 2. Now don't do A cube minus B cube formula over here because it is equal to 2 on the other side. Okay. So this will give me B cube minus A cube is equal to 2. Now there are two cases. B is A or B is equal to minus A. So guys, you tell me, can B be equal to A? Can B be equal to A? There are two cases, right? B is equal to A or B is equal to minus A. So can B be equal to A? If B is equal to A cube minus A cube should give you 0, but then we are getting 2. So B cannot be equal to A. Okay. So two cases. B is equal to A. Therefore, A cube minus A cube is equal to 2. 0 is equal to 2. Case discarded. Okay. And if B is equal to minus A cube equal to minus 1. Okay. So A cube plus 1 is equal to 0. A cube plus 1 is equal to 0. So A cube plus 1 cube. A cube plus 1 cube. So A plus 1, A square plus A plus 1 equal to 0. Okay. So A plus 1 is equal to 0. A is equal to minus 1. Since B is equal to minus A, B is equal to minus of minus 1, B is equal to 1. This is first answer. Second case, A square plus A plus 1 is equal to 0. We'll find out delta. B square minus 4AC. B is 1 this time. A is 1, C is 1. Delta lesser than 0. Roots are complex. So we cannot take complex value of A. So we just have to take the real value of A. That is minus 1. So if A is equal to minus 1, B is equal to 1. This is your solution. This is your solution. Question number 10, sub question 3. Let us begin. उसके पहले just give me a feedback of this. Have you understood this? Share your feedback, please. Yeah, 10 sub question 3. So left hand side 0 to 1 f of dx. Okay, 0 is a lower limit. A plus bx plus cx square. Integration of A is ax. Bx is bx square by 2. Cx square is cx cube by 3. Okay, 1 and 0. Box minus box. A into 1. B into 1 square by 2. C into 1 cube by 3. A into 0. B into 0 square by 2. C into 0 cube by 3. This entire box is 0. So this is going to be A plus B by 2 plus C by 3. This is your left hand side. This is your left hand side. Any doubts in the left hand side? Okay, we'll start with the right hand side. Before we start with the right hand side, we'll first calculate three values. Okay, so f of x is equal to a plus bx plus cx square. So f of 0, a plus b into 0, c into 0 square, which is equal to a. F of half, a into a plus b into half plus c into half square. So a plus b by 2 plus c by 4. And f of 1, a plus b into 1 plus c into 1 square, a plus b plus c. A plus b plus c. Okay. Now we will start with the RHS. Right hand side, 1 by 6 f of 0 plus 4 into f of half plus f of 1. Okay. F of 0 is a, f of half is a plus b by 2 plus c by 4. F of 1 is a plus b plus c. So you simplify this and check whether you are getting the same value as that of the LHS. Simplification part, I leave it up to you. You can do it at home later on. Okay. So last problem for the day. After this, we'll wind up. Question number 10, sub question 4. Integration 0 to k dx 2 plus 8x square. 8x square plus 2 dx. Okay. So this value is equal to pi by 16. Okay. This value is equal to pi by 16. So let's not write I equal to. Let's just write it as equal to pi by 16. 2 common. 4x square plus 1 k and 0. 4x square plus 1 k and 0. So this is going to be 2 ones are 2, 8s are. So 0 to k, 1 upon 2x the whole square plus 1 square dx is equal to pi by 8. Okay, so this is x and this is a. So 1 upon a tan inverse x by a. That's the formula. So 1 upon 1 tan inverse of 2x upon 1. Okay, upon d by dx of 2x, so there will be 2 down over here. The significance of this 2 is it's a chain rule. D by dx of 2x. 2x is LAT. So 2 ones are 2, 4s are. Okay. But then we have upper limit and lower limit as well. K and 0. So box minus box. This is pi by 4 over here. Tan inverse 2k upon 1 minus tan inverse 2 into 0 upon 1. Upper limit and lower limit. Tan inverse 2k upon 1. Okay. So tan inverse 2k minus tan inverse 0. Tan inverse 0 is going to be 0. So tan inverse 2k is equal to pi by 4. Therefore 2k is equal to tan pi by 4. What is tan pi by 4? What is tan pi by 4? What is tan pi by 4? 1. Therefore k is equal to half. That is your answer. Okay. Chalo, thanks.